Hi guys, hope you're doing well. Hope you guys are studying hard as exams gets closer and closer. For those that don't know me, my name is Daniel. I'm a GCSE and A-level maths tutor, and I've been tutoring for about 6 years now. And yeah, so today we've got the Edexcel GCSE Maths Paper 1, so non-calculate paper, higher tier for summer 2023, so last year's paper. And having done the solutions, I definitely think this was an okay paper. I don't think it was particularly unreasonable. I don't think it was the hardest paper in the world. There were definitely some tricky parts, especially the quadratic inequality in question 24, the last question. But if you've done your revision, you know your exact trigonometric values, you know your surds, and everything else, you should be fine. As well as that, you guys will also have the timestamps in the description. So if you want to go to a specific question, then you can do so quite easily. And yeah, that's pretty much it from me. Let's get into it. Okay, so question one says we need to work out 8.46 divided by 0.15. Okay, this is a first on a non-calculate paper, and we're dividing decimals. So it looks a bit daunting, but what you want to do, especially when you get something like this on a non-calculate problem, is just to convert these into whole numbers. So I'm going to write this as a fraction. So I've got 8.46 over 0.15, and you'd want to convert these decimals into whole numbers. And we can do that by just multiplying by 100 top and bottom, isn't it? So I'm going to do this here and do this here. This will give me 846 on the top. It's going to be 15 on the bottom. So remember, if I wanted to work out this fraction on the left, it would be the exact same as working out this fraction on the right because they're equivalent. But the good thing is with this one, it's quite easy to use the bus stop method now. So we're going to work with this one. So I'm going to do 15 here. Put 846 here. This, and then, well, firstly, how many times does 15 go into 8? It doesn't, so we have to bring the 4. So we ask ourselves, how many times does 15 go into 84? Now, remember your times tables will be key here. So 15 times 5, you should know, is equal to 75, meaning that we can see quite clearly that 15 will go to 84 5 times, right? So I'm going to put a 5 here. What would the remainder be, though? And I'm at 75, I need to get to 84, that's just 9. So I'm going to put a 9 right here next to the 6. So now we have to ask ourselves, how many times does 15 go into 96? Now, if 15 times 5 is 75, then 15 times 6 is just going to be 90, isn't it? Meaning that we can see quite clearly that 15 will go into 96 6 times. So I'm going to put a 6 here. I'm going to put a point here just to line these up. Now, what would the remainder be? Remember, we are at 90. We need to get to 96. That's just a 6 here, isn't it? A remainder of 6. So now we just ask ourselves, how many times does 15 go into 60? And that's quite clear. That's quite clearly 4, isn't it? So the answer is just going to be 56.4. So we can just say 8.46 divided by 0.15 is just equal to 56.4. And we're done. That's question one. Okay, so question two says we need to work out 7 and 3/8 minus 2 and 1/2, and we need to give our answer as a mixed number. Okay, so for this one, we've got mixed numbers as it stands. We need to convert these into improper fractions first. Take them away and see what our answer is. So I'm going to go ahead and start with this one. I've got 7 and 3/8. Now, how do we do this? We always multiply these two numbers together. 8 times 7 is 56. So I'll just times this here, put 56 here. And then we have to add on this numerator here. So 56 plus 3 is 59. So therefore, it just becomes 59 over 8. That's the first one. And then the second one, we have 2 and 1/2. So we're going to do 2 times 2, which is just 4. And then we're going to add on 1, which is going to be 5. So therefore, we can have 5 over 2. So now the question just becomes 59 over 8, take away 5 over 2. Now remember, when we subtract or add fractions of different denominators, we need a common denominator, which is typically the LCM. And if I look at the 8 and the 2, the LCM is just going to be 8, isn't it? Meaning that I can write both denominators with 8, like this. This here. Now, this already had an 8, so I'm going to keep this the same, 59 over 8. And in this one, well, how do I go from a 2 to an 8? I multiply by 4. Because fractions have to be equivalent, I have to do the exact same to the top here. So I'm going to times this by 4, because this one had to times by 4 as well. So it's going to be 5 times 4, which is 20. So therefore, we get 59 over 8 minus 20 over 8. Now, since the denominators are the same, I can just combine the numerators. So it'll be 59 take 20 over 8, which is the same as 39 over 8. Now, they said we need to give an answer as a mixed number. So this is pretty easy. We just need to ask ourselves, well, how many 8s going to 39? It will go 8, 16, 24, and then 32, right? So we can see quite clearly that there are 4. So our answer, I'll do it right here. It's going to be a big 4 at the front. And then, well, it's at 32. How many is remaining? How many numbers do we add to go from 32 to 39? It's just 7. So it's going to be 4, 7, and then over 8. So that's just 4 and 7/8. And that is question 2. Okay, so question 3 says a cube has a total surface area of 150 centimeters squared, and we need to work out the volume of the cube for 4 marks. Okay, so with this one, what I would do firstly is draw a picture of a cube. So I'm going to just draw a square like this, like that. And then I'm going to draw another one like this here. Like that. Hold on, let me just do it one more time, just so it's a bit neat. Okay, perfect. Now I'm going to connect these. I'm going to connect these here, connect these here, connect these here, connect this here. Now remember, a cube is just a 3D object where each of the faces are squares, right? So all of the lengths are the same. Now they've asked us for the volume, right? Now we know that the general formula for the volume is just the width times the length times the height. So I'm going to write width times length times height. Now, as I said before, a cube has all of the faces to be squares, meaning that all of the distances of each of the sides here are going to be the same. So what I can do is say, well, I don't know what these sides are, but I'm going to call them x, right? So I can say x here, x here, and x here. That would mean that the volume will just be equal to x times x times x, which is just x cubed, right? So essentially, this is our answer here, but it's our job to figure out what x is. Now, they've given us a bit of information. They've told us that the cube has a total surface area of 150 centimeters squared. Now, remember, to work out any surface area of any object, you just add all of the areas of all of the sides, right? Now, we know that we're dealing with a cube. Each face is the same. They're all squares. So what we could say from here is essentially that the total surface area would be the area of the 6 faces, right? And we could say that the 6 faces then must equal 150 centimeters squared, right? Because they're all exactly the same. Now that helps us because what we can do from here is work out the area of one face, right? So to work out the area of one face, all I would do here is just divide by 6. So I could just say that one face is just going to be 150 divided by 6. Now we don't have a calculator, so we're going to use the bus stop method. So I'm going to have a 6 here, and then I'm going to have 150 here. Now, how many times does 6 go into 1? It doesn't, so we need to bring the 5. How many times does 6 go into 15? It goes in twice because 6 times 2 is 12, and it has a remainder of 3, doesn't it? So I'm going to put a 3 here. Now, how many times does 6 go into 30? It goes in 5 times, meaning that 150 divided by 6 is just 25. So we can say that the area of one face is just 25 centimeters squared. Now remember, one face is just one of the sides, which we know is a square. So what I'm going to do here is I'm going to just draw one of the faces here like this. And we know that the area of this is a 25. And we also know that the base and the height are both x's, meaning that we can construct an equation for the expression for the area. We could say that we have x times x, which is x squared, and this has to equal 25. So therefore, we can use this to figure out what x is. So we can say x is just equal to the square root of that, which is just 5. Now, normally we do plus or minus, but remember, we're dealing with a distance here, so we just choose the positive version. So x is equal to 5. Now, why is this helpful? Because remember, at the end of the day, we need to find the volume of the cube, which we know is x cubed. So we could say here, well, the volume we know is just equal to x cubed, but we know x is 5, so it's just 5 cubed, which is just 125. So the answer is just 125 centimeters cubed. And that's it. That's question 3. Okay, so question 4 says the table shows information about the daily rainfall in a town for 60 days. We've got the rainfall in millimeters on the left and the frequencies on the right. And it says we need to draw a frequency polygon for this information for 2 marks. Okay, so this is very, very simple, right? All you want to do is your class intervals here. You want to get the midpoints and you're just going to plot those with the frequency. So what I would do just to be super safe as I'll just create another column. You don't have to, but that's what I like to do. I'm going to call this midpoint. It's going to be the midpoints of all of the class intervals, so the rainfalls. Do this here, do these here, do these here, and do these here. So now in this case, halfway between 0 and 5 is going to be 2.5. This is going to be 7.5. This is going to be 12.5. This is going to be 17.5. It's going to be 22.5. So all we're going to do is just plot these as x coordinates and plot these as y's, essentially. So in this case, let's do the first one. The first one is 2.5 and 8. So where would that be? 2.5 is right here, and 8 is just right here, isn't it? So I'll put a point right here. Next one is going to be 7.5 and 24. 7.5 is right there. 24 is just going to be just 1 under 25, so right here. So that's fine. And then the next one is 12.5 and 13. 12.5 and 13. So 13 is going to be 11, 12, 13 is going to be right here, like this. And then the next one's going to be 17.5 and 11. So it's going to be 17.5 is here, 11 is right here, like this. And then the last one is just 22.5 and 4. So 22.5 is here and 4 is right there. Now, once you've plugged all of these points, all you're going to do is just connect these with straight lines. So what I'll do is I'll just do this here, and I'll just do it do it here, and I'll just start from here and work like this. I think sometimes it could take quite a while to do these. So what I'll do, let's just see how long it takes. So that would be one, and then this would be another one here, and I'll just connect these nicely at the end. Okay, so it'll be like that, and then I'll do the next one, which will be like this, like there, like there, and the last one will just be like this. Okay. But yeah, that's pretty much it. That will give you the 2 marks, and that's question 4 finished. Okay, so question 5 says we've got the universal set, which is numbers 1 to 10, and set A is the set of odd numbers, and set B is the set of square numbers. We need to complete the Venn diagram for this information for 3 marks for part A. Okay, so with this type of question here, what they like to do is they like to describe sets. So, for example, they've given the set A as odd numbers and the set B as square numbers. So, what you'd want to do is essentially rewrite these sets with the actual numbers at hand, right? So what we can see here is that the universal set will have all of the numbers here. So what we're going to say is that for set A, we're just going to choose all of the odd numbers in the universal set. So I'll just use my highlighter. So in this case, well, odd one is an odd number, so it's 3, 5, 7, and 9, right? So therefore, I'm going to have 1, 3, 5, 7, and 9. That's fine. And then square numbers for set B. Remember, a square number is just any number that you can square root nicely, essentially. You square root the number and then you'll get a whole number out. So we could just do this bit by bit now. For example, the square root of 1 is just 1, so that's fine. Square root of 2 isn't you don't get an integer when you square root 2, nor do you get an integer with 3, but you can square root 4. The square root of 4 is 2. So this will be another one. So I put 4 here. And then now the next one, 5 you can't, 6 you can't, 7 you can't, 8 you can't, but 9 you can. The square root of 9 is 3. So therefore we can have a 9 here, and then the square root of 10 isn't an integer. So these are the 3 square numbers here, 1, 4, and 9. So now we've got our numbers here in terms of our sets A and B. What do we do now? Well, what I always do with these questions is I always start with the intersection, the overlap. So I can see that I've got a common number of 1 in both. Are there any more? I can see a 9 as well, right? I think these are the only 2 numbers that are the same. So I would say I have a 1 here and a 9 here. Now, when I look at the rest of the sets here, I can see that, for example, for set A, I can see I'm left with a 3, 5, and a 7. That will go in the outer part of A, so 3, 5, and 7. And then again for set B, I just have a 4 here, don't I? So I'm going to put a 4 here, like this. Now, remember, we're not finished because we've done all of the numbers in both sets. Now, we need the outside, don't we? And those are the numbers that we haven't used. So we have to go back to our universal set, and I'll get another highlighter. I can see that we haven't used a 2, we have used a 4, we haven't used a 6, we haven't used an 8 anywhere, and we haven't used a 10. So therefore, the numbers that will go on the outside will just be 2, 6, 8, and 10. And this will be our completed Venn diagram. So that's part A done. Now, part B says that a number is chosen at random from the universal set. We need to find the probability that this number is in the set B dash. Now, remember, when you have this dash here, what this means is that B dash is just equal to the complement of B, right? Essentially, the values that are not B. So all you need to do here is just ask yourself, well, what are the values that are not B? Well, there's quite a few. There is how many are there? Essentially, there's 1, there's 2, there's 3, there's 4, there's 5, there's 6, and there's 7. So therefore, the probability, remember, probability is a fraction. We know that it's going to be the amount of numbers that aren't in B, which is 7, out of the total, which we know the numbers from 1 to 10. So the answer will just be 7 over 10. And that will be our answer for question 5. And that's done. Okay, so question 6 says the scatter graph shows information about the ages and weights of some babies. we've got the weight on the vertical axis and the age on the horizontal axis. And part A says we need to describe the relationship between the age and the weight of the baby. So for this one, what you want to do is just describe the type of correlation when you're dealing with these types of questions. We ask you to describe the relationship, but it's also good to have an understanding of what's going on too. So as well as that, you can see, well, as the age is increasing here, you can see that the weights are increasing too. So you can say something along those lines as well. So what I'll do is I'll just put this here. So for that one, whoops. Okay, let me go back to it. Yeah, right here. So we could say for that one, uh, as the weight, as the age increases, as the age increases, the weight increases, the weight increases. And you could just put positive correlation as well, or in brackets, but either one of these would be perfectly fine. Correlation. And that will give you the 1 mark. Pretty much it. So we've done that. Now the next question says another baby has a weight of 5.8 kilograms, and using the scatter graph, find an estimate for the age of this baby. So with this one, we know that what we need to do, we need to draw a line of best fit. So that's just a line that just best fits the data. So what I'm going to do is I'm going to draw a line like this. So I think for me, that looks like a good line. That looks like a good line to me. Maybe it could be better, but this should be okay. That's not too bad. Let me just extend it a little bit. This here. Okay, that's fine. And then I'll just extend it a little bit like this here. Yeah, that looks fine to me. Now, the question said that another baby had a weight of 5.8 kg, and we need to find the age, estimate the age. So what you're going to do is just go to 5.8 on your vertical axis here. So we can see that this is going to be 5. It's going up in 0.2s, isn't it? 5.2, 5.4, 5.6, 5.8. 5.8 is right here. So we're just going to go to that on our graph, like this here. This, which seems to be right here. And then now we're just going to go down to see what age that would be. So it'd be around here, essentially, like this here. And this is 3. This is going to be 3.8. So it looks to be 3.9, isn't it? Halfway between 3.8 and 4 is 3.9. So we could just say that this is just going to be 3.9 months. And that would be it. And obviously, everybody's line of best fit would be slightly different, but it should get the same whereabouts the same thing. So there would be a range of answers. So 3.9 will definitely be inside. So that's fine. And that is a question 6. Okay, so question 7 says the price of a holiday increases by 20%. This 20% increase adds 240 to the price of the holiday. Work out the price of the holiday before the increase. Okay, so these type of questions comes up quite a lot. They've told us about a percentage increase, right, which is in this case is 20%, but they've also told us what this percentage increase equates to, right? This 20% increase adds 240 to the price of the holiday. That must mean that the 20% has to equal the £240 for sure. Now, if we want to work out the price of the holiday before the increase, well, that's just working out what 100% is, isn't it? So we have to figure out what 100% is. So we're going from 20% to 100%. That means we just need to multiply by 5, meaning that we need to multiply the 240 by 5. So we could just do this using the column method. So I'll put this here. So 5 times 0 is 0. So put that there. 5 times 4 is 20. So I'm going to put a 0 here and I'm going to put a 2 here. 5 times 2 is 10. I need to add that 2 to give me 12. So it's just going to be £1,200. And that's it. That's question 7 finished. Okay, so question 8 says the diagram shows a solid cylinder on a horizontal floor. It says that the cylinder has a volume of 1,200 centimeters cubed and a height of 40 centimeters. The cylinder exerts a force of 90 newtons on the floor. Work out the pressure on the floor due to the cylinder. And we've got the formula for pressure in the right hand corner. Pressure is equal to force over area. So what we need to do is, well, we can see that they've given us the force here. So we could just say, for example, the pressure, which I'll call P, is going to be equal to the force over area. We know that the force is 90. So it's going to be 90 over the area, which I'll call A, right? So our job is to figure out what the area is. Now, they've given us a bit of information about this cylinder, which is a prism, right? Now, we can see that the volume of it is 1,200. So what we need to do is remind ourselves of the formula for the volume of a cylinder. the formula for the volume of a cylinder is just going to be pi r squared, right? The area of the circle multiplied by the height, right? Which is why I said it's a prism, isn't it? Remember the formula for the volume of a prism? It's the area of the cross section times the length it goes across. So in this case, the area of the cross section will just be the face here, right? And then the length it goes across will just be the height here, isn't it? So it'll be the height here. That's fine. So then in this case, we can say, well, the volume then is just going to be equal to the area, right? Multiplied by the height. Now we know two of these. We know the volume is 1,200, so 1,200. And then we've got the area times by h, which is 40, meaning that we can rearrange to find the area. So we're going to have 1,200 divided by 40, which is equal to the area. Now this is very simple to work out, so let's go ahead and do this. We can say that then the area then is just going to be equal to, if I cancel this here, it'll be 0, 0, that will cancel. It'll be 120 divided by 4, which is just 30. So we now know the area is 30 and this will be centimeters squared. So therefore the pressure, remember we know is force divided by the area. We said it was 90 over A. So it's going to be 90 over A, which we now know is 30. So the pressure is just going to be 90 over 30. Again, the zeros cancels, is 9 over 3, which is just 3. So therefore, the answer is just 3 newtons per centimeter squared. And that will be our answer for question 8. Okay, so question 9 says we need to use these graphs to solve this simultaneous equation. 2 minus 2y is equal to x and 2y is equal to 3x minus 22. And they've given us these graphs in this grid here. So whenever you're trying to solve a simultaneous equation graphically, it's just the points of intersection of both the lines. So it's very, very simple, which is why it's only 1 mark. So all you're going to do is just find the coordinate of the point of intersection, which is going to be right here. So if I go up to the x, right, though that's clearly it's going to be 6 right here, and this one is going to be -2, isn't it? So therefore your point of intersection is just going to be, I'll do it here, 6, -2, and that will be your answer. So we could just say x is equal to 6 and y equals -2, and that's question 9 finished. Okay, so question 10 says, here is a pentagon, and they've given us a couple of the angles. They've told us that angle AED is equal to 4 times angle ABC, and we need to work out the size of angle AED, and we must show all your working for 4 marks. This is a 4 marker. So the first thing that I will do is label the angle in question. So angle AED is clearly this one. I'm going to call this X. And then they've told us that this angle is 4 times angle ABC, which is this one, which I'm going to call Y. So if I do this here, then I can say, well, from this equation here, I called this one X, I called this angle Y. So we can say that this equation here is just X is equal to 4Y, isn't it? Meaning that all we need to do to figure out the answer is figure out what Y is and then times it by 4, and that will give us X. Now, this is one way to express this type of relationship. This comes up quite a lot where they say something is maybe 4 times another. Another way to think of it is ratios too. So if angle AED is 4 times angle ABC, well, it means for every 1 of angle ABC, there's going to be 4 of AED, right? Because it's 4 times. So we could just say that AED and ABC are in the ratio 4 to 1, isn't it? So we could do it like this as well. Now, the main thing here, though, is that we're dealing with a pentagon, which is a polygon, right? It's not a regular polygon because the interior angles are different, but it's a polygon all the same. Now, to work out the sum of the interior angles of a polygon, you just do n minus 2 times by 180, where n is the number of sides of the polygon. Now, a pentagon has 5 sides. So what I'm going to do is I'm going to put here, I'm going to say a sum of int for interior, sum of interior angles, right? This is just equal to n minus 2 times by 180. Now, in our case, we know that n is 5, so we're going to just say that we've got 5 take 2 times 180, and this is just equal to 3 times 180. And I know that 3 times 18 is 54, 54 times 10 is 540. So therefore, the sum of all of these angles have to make 540. That's very helpful because all we need to do now is just add up the angles that we know, take it from 540, and then use the ratio or use these equations to figure them out. So let's go ahead and do that. So I'm going to add these angles here. So I'm going to do it here. It's going to be 135 plus 120 plus, sorry, do it here, plus 110. Adding these up together, it's going to be 5. 3 plus 2 is 5 plus 1 is 6. 1 plus 1 plus 1 is 3. So it's 365. So now we've got this here. all we need to do is just take this from 540. So I'm going to do 540 take away 365. And doing this, we can't do that. So I'm going to borrow one here. So I'm going to put this as 3. So we have 10. 10 minus 5 is 5. 3 take away 6 we can't do. So I'm going to borrow one from here. It's going to be a 4. Put a 1 here. 13 take away 6 is 7. 4 take away 3 is 1. So 175. Meaning that these two angles that we don't know, X and Y, they must make 175 degrees. Now we know that this is in the ratio of 4:1. Now remember, with ratios, you're just expressing a quantity in parts, right? So what we're saying here is that we've got the ratio of 4:1, like this, and we know that this must make 175 degrees. Meaning that, well, we've got 4 and 1 part, that's 5 parts altogether. This is going to give you 175 degrees. So we can work out what 1 part is just by dividing by 5. So I'll go ahead and do this. Use the bus stop method. 5 doesn't go into 1, but 5 goes into 17 3 times with a remainder of 2. So that means that, well, 5 will go into 25 5 times. So therefore, 175 divided by 5 is just 35 degrees. So now to remember, the question asks us to work out angle AED, which was the 4 parts. So we're working out what 4 parts is. So we're going to say, well, 4 parts is just going to equal 35 degrees times by 4. And this is just 35 times 2 is 70, times by 2 again is 140. So the answer is just 140 degrees. And that is our answer. And that is our question 10 finished. Okay, so question 11 says, write 6x to the 5, y to the 3 all squared, divided by 3x squared, y to the 7, multiplied by 4x, y to the negative 3, in the form ax to the power of b, y to the power of c, where a, b, and c are integers for 3 marks. Okay, so this one is pretty straightforward, right? It does look a bit tricky, but just break it down bit by bit. Now, I'm going to start with the numerator here because we've got a square, right? There's a couple of things going on here, but it's all being squared. So that would mean that, for example, we have 6x to the 5, y to the 3. And if it's being squared, it means that we could just multiply it by itself twice, isn't it? So like this, and then like this here, 6x to the 5, and then y to the 3. Now, doing this, you're just going to do the numbers, the letters individually. So 6 times 6 is 36. X to the 5 times x to the 5. Remember your index laws, you add the indices together. So it's going to be x to the power of 10. And then it's going to be y to the power of 6, isn't it? So that will be the numerator. So I'm going to write the question again. So it's going to be 36, x to the 10, y to the 6. And then the denominator, well, we're doing 3 times 4. If I just do the exact same thing I did before, 3 times 4 will be 12. This x to the 2 times by x is going to be, remember, x is x to the 1. This is going to give me x to the power of 3. And then I've got y to the 7 multiplied by y to the negative 3. Now remember, you're multiplying them, so you add the indices. So you're going to be doing 7 plus minus 3. I'll just do it here. So we'll just do y to the 7 times by y to the minus 3. This is going to be y to the power of 7 plus minus 3. We know that a plus and a minus make a minus, so it's 7 take 3, which is equal to y to the 4, meaning that this is y to the 4 here. Now, when I get here, all you need to do is just do these individually. So you're going to work out what this is here, work out what this is, work out what this is here, then work out what this is, and then bring them all together. So doing this, 36 divided by 12, right, is 3. X to the 10 divided by x to the 3. Remember, you're going to take away the powers now because we're dividing. It's going to be x to the power of 10 take 3, which is 7. And then we've got y to the 6 divided by y to the 4. So 6 take away 4 is 2. So therefore, your final answer is just 3x to the 7, y to the 2. And that's it. That's question 11 done. Okay, so question 12 says Martha plays a game twice. The probability tree diagram shows the probabilities that Martha will win or lose each game. So we've got the first game probabilities and the second game. And it says we need to find out the probability that Martha will lose at least one game. Now, when you're dealing with these types of probability tree questions, right, look at the question. It asks us to find the probability that she loses at least once, right? What I like to do is list the scenarios whereby that can happen before I start working things out. So we're losing at least one game. So I'm going to write probability of at least, oh, let me write lose first, actually. Lose at least once. So lose at least once. Now, how can that happen? How can you lose at least one game if you're playing twice? Well, firstly, you could win the first game and then you could lose the second game. That is one option, right? So I'm going to just write probability. This could be W for win, and then I'm going to and then L for lose. That is one way it can happen. Or you could lose the first game and then you could win the second game. So we could say W, so we could say L and W for lose and then win. Or remember, it says at least once. You don't have to lose once. You could lose twice. So you could just lose both games. So it could be probability of L losing and then another L. Like this. And these three here would be the different scenarios whereby this probability can happen. So what you would need to do is work out all of these individually, and then you've got to remember a couple of things when you're dealing with probability trees. You've got two things to remember. When you're dealing with the word and, this just means to multiply. And when you're dealing with the word or, you just add. So we can see quite clearly that these all would be and. So we work out these, whatever they are, and then add them together, and this will be our answer. So let's go ahead and work these out. Now, when you're dealing with trees, so firstly, the probability of us winning and then losing, you just look along the branches. We win one game and we lose the other. So you're just going to multiply these probabilities here because it's and win and lose. So this one here will just be 5/8 multiplied by 7/9. That will be the first one. And then this one, lose and then win. This will be 3/8. 3/8 is losing, and then winning is timesing by 2/9. That'll be the second one. And the last one, lose and then lose, is going to be 3/8 multiplied by 7/9. So all we need to do now is just work out all of these, and then remember the ors mean that we add them together. So this here is going to be our answer. We just need to simplify everything. So let's go ahead and do that. This one here, remember how we multiply fractions? We just multiply across. 5 times 7 is 35. So it's going to be 35 over 8 times 9 is 72. Plus 3 times 2 is 6. 8 times 9 is 72. And the next one, again, is 3 times 7, which is 21. 8 times 9 is 72. So this here is going to be an answer when we work this out. Now remember, they've all got the same denominator, so we can just add the numerators together. So we've got 35 plus 6 plus 21. This is all over 72. Now working this out, 35 plus 6 is 41. If I add 21 to that, that will give me 62. So the answer is just going to be 62 divided by 72. Or if you want to simplify this, you could just divide both sides by 2, top and bottom. So it'll be 31 over 36. Now, either one of these will be perfectly fine in the exam because it didn't specify whether or not you need to simplify or not. So this is it. This is question 12 done, and that was 3 marks. Okay, so question 13 says, y is directly proportional to x. Y is equal to 24 when x equals 1.5. Work out the value of y when x equals 5. Okay, so this one is very, very straightforward as long as you know your direct and inverse proportion, right? Now, they've told us that y is directly proportional to x, which we could write as this here. And this would be represented by the equation y is equal to kx, right? Where k is your constant of proportionality. So all we need to do now is plug in the values that they've given us to find out what k is, plug that back into the formula, and that will give us y when x is 5. So let's go ahead and do that. So in our case, we know that when y equals 24, x is 1.5. So I'm going to put 24 is just equal to k and then times 1.5, right? And that is our y and x plugged in. So we could just write this as 24 is equal to 1.5k, isn't it? Meaning that k would just be 24 divided by 1.5. Now to work this out though, because I have a decimal here, I don't really like it. But remember, fractions are equivalent. What I can do is just get rid of that decimal by turning it into an integer. And we can do this just by timesing it by 2. So I'm going to times this by 2 here. So this will become a 3. But remember, fractions have to be equivalent. So I have to do the same on the top. It's going to be 48 here. If I do this and that, times by 2. So we're just working out what 48 divided by 3 is, which I know is 16. So therefore, that tells us that our k is equal to 16. Meaning that this equation here, y equals kx, I can update it to say that y is just equal to 16x. Now the question asks us to work out the value of y when x is 5, so we're just going to plug in x equals 5. So it's just going to be 16 times 5, which is just 80. So therefore y is equal to 80. And that is our question 13, and that is 3 marks. Okay, so question 14a says we need to write 1 over 16 in the form 4 to the power of n, where n is an integer, for 1 mark. Okay, so these types of questions here is just having good knowledge of your index laws. So with this one, I've got 1 over 16. Now, naturally, even if you don't really know much, straight away, I can see a 4 here, and I've got 16. We could rewrite this as 4 squared, right? 16 is the same as 4 squared. Now, there is an index law that states if I have 1 over a to the power of n, this is just equal to a to the minus n. You just put a negative on that power to make it the reciprocal. Now, if I compare this to what I have, I've got 1 over 4 to the power of 2. And just by copying that same structure, this must be 4 here, and this is going to be minus 2. So therefore, the integer n is minus 2, and your answer is just 4 to the minus 2. And that's part A. Now, part B says we need to work out the value of 8 to the power of 5/3 minus 9 to the power of 3 over 2. Now, I've got fractional indices here. So with this one, again, good knowledge of your index laws is super, super important. So there's a couple of index laws going on here. Now, firstly, what I will do is say, well, if I've got a to the power of 1 over n, right, this is equal to the nth root of a. That is one law that we're going to have to use here. And another law is a to the power of b multiplied by c is just a to the b all to the power of c. We can put one power inside and put the other one on the outside. These are two rules that we're going to use here, and you're going to see why. So for example, I've got 8 to the power of 5 over 3. Now, 5 over 3 can be written as a product. It can be written as 1/3 multiplied by 5, isn't it? 1/3 times 5 is the same as 5/3. Now, with that being said, if I look at this second rule here, that means I can put one of the powers inside, 1 over 3, and then I can put the 5 on the outside. Now, because multiplication is commutative, we can put it in either order. We can put the third on the inside and the 5 on the outside, or we can swap it around. But you want to be clever. You have a non-capital exam. We know that the 8 to the power of a third is the same as taking the third root or the cube root, isn't it? So in that case, the cube root of 8 is something that we're familiar with, right? So I'm just going to write this as the cube root of 8 all to the power of 5. And that is that one. We're going to work it out in a second. Let's just do the second one now. So I've got that one done. Now 9 to the power of 3 over 2. Again, we can write this as 9 to the power of 1/2 times by 3. So 2 here times by 3, meaning that we can just write this as 9 to the power of 1 over 2 and then put the 3 on the outside. And then we know that this here just means that it's the square root of 9, isn't it? So we've got these here, meaning that the question here actually just becomes the cube root of 8 all to the power of 5 minus the square root of 9 all to the power of 3. Now, working each of these out, the cube root of 8 is 2, so 2 to the 5, and then the square root of 9 is 3, isn't it? So it's just going to be 3 to the power of 3. Now, this here, 2 to the 5, you can just keep times them by 2, but this is just 32. And then the cube of 3 is 27. So therefore, the answer is just 32 take away 27, which is just 5. So the answer is just 5. And that is part B of question 14. And yeah, that's it. Okay, so question 15 says the equation of line L1 is y equals 2x minus 5. The equation of line L2 is 6y plus kx minus 12 is equal to 0. L1 is perpendicular to L2. Find the value of k. You must show all your work in it. This is a 3-mark question. Now, straight away, this is an equation of lines question, and they've told us about lines being perpendicular, right? That is a very key word, perpendicular, because when two lines are perpendicular, there is an implication for the relationship of their gradients, right? And that is that the gradients of one of them is going to be the negative reciprocal of the other, right? In other words, when you multiply the two gradients together, you'll get -1. Now, for this one, we need to find the value of k, meaning that we need to form some sort of equation. So the way I'm looking at this question is, I'm saying to myself, well, I know what the equation of line L1 is. There's no letters here, right, in terms of any other variables. It's just all in terms of y and x. The gradient of y equals 2x minus 5, which is L1, right, is just going to be the number in front of the x term, which is quite clearly a 2 here. So I'm going to say that the gradient, I'm going to say grad of L1, right, is equal to 2. Now, the gradient of L2, right, is the negative reciprocal of this number here. Now, remember, how does the negative reciprocal work? If I have a gradient m, then the negative reciprocal will just be -1 over m. You just do 1 over the number. Or in other words, if we have it as a fraction, m over 1, you just flip it. So in this case, the gradient of L2 would just be -1 over 2. So that's fine. Now, we know the gradient of L2 is -1 over 2, but we've got an equation for L2 and there's a k here. So what we would want to do is rearrange this to find an expression for the gradient of L2 in terms of k, and then we can just equate it to -1/2, and then we have that equation formed that we can easily solve. So let's go ahead and do this. I've got 6y plus kx minus 12 is equal to 0. If I move the kx and the minus 12 over, I will have 6y is equal to, that will become a minus kx. The minus 12 will become a positive 12. And then now I need to divide everything by 6 to get y. So I'll have y is equal to, and it will just be minus k over 6 x plus 12 over 6, which is 2. And then again, quite clearly, the gradient of L2 in terms of k will just be the number or the expression in front of x, which is quite clearly minus k over x. And we know that this is representing the gradient of L2, which we know is minus a half. Meaning that what I'll do, let me just underline these in green. This is the gradient of L2, and so is this one. It means that they are equal to each other. So I can just say from here that minus k over 6 must be equal to minus 1 over 2. And then now we have an equation that we can easily solve. If I times both sides by minus 1, that will get rid of the negatives. I'll have k over 6 is equal to 1 over 2. And then to get k, we can just see that we need to times by 6. So I have k is equal to 6 times a half, which is just equal to 3. So therefore, k is equal to 3. And that is our final answer. And that's this question finished. Okay, so question 16 says, here is a sphere. The surface area of the sphere is 4 pi r squared, and 3/8 of the surface area of this sphere is 75 pi centimeters squared. Find the diameter of the sphere. Give your answer in the form a root b, where a is an integer and b is a prime number. Okay, so for me, whenever I'm doing questions such as this, right, what are we looking for then? We're looking for the diameter. We know that the diameter is just 2 times the radius, right? So for me, this is what we're looking for. We're looking for d. Now, d is equal to 2r, meaning that to answer the question, I need to find out what the radius is somehow, some way. So our job here is to figure out what r is. That's the main thing. So be very robotic with these types of questions. Think about what your end goal is. You need to find d. To find d, you need r. So we need r. Now, continuing. Now, we've got a statement here, right? We've got a sentence. It says 3/8 of the surface area of this sphere is 75 pi centimeters square. Now, this is just an example of an algebraic worded problem. And I say this to my students all the time. They give you some sentence in English, and then it's your job to translate this sentence in English into a mathematical equation. So we're going to go ahead and do this. So firstly, I've got 3/8, right? If I wanted to translate this, I have 3/8, that's fine. And then I've got the word of. I've got of, to be fair, I can highlight these two, of the, right? Now, if you're taking a fraction of something, remember of is just the same as multiplication. So I can write this as 3/8 multiplied. And then the next part says the surface area of the sphere, right? Now we know the general formula for the surface area of a sphere is right here. They've given it to us, right? It's 4 pi r squared. So I'm going to put a 4 pi r squared here. And then the next part of this sentence is this word is, right? Now, if something is something else in maths, it means that they are the same, which means they are equal. So that word is just another way of saying two things are equal. So I can put equal here, and then we've got 75 pi at the end. So I'll just highlight that too, just so it's super, super clear. 75 pi. So therefore, we get this equation here. And what's happened here is that we started with this sentence in English, and then we've translated it into a mathematical equation, and that's all you need to do. And this is very helpful because now we have an equation in terms of r that we can solve, and then we can plug that back into the equation for d, which is 2r. So let's go ahead and do this. Let's tidy this up first. Now, firstly, I've got 3/8 times by 4. That will give me 12 over 8, wouldn't it? So I'll get 12 over 8 pi r squared. This is equal to 75 pi. Now, what can I do? The 12 divided by 8 can simplify. Divide top and bottom by 4. I'll have 3 over 2 pi r squared is equal to 75 pi. Now, I've got a factor of pi on both sides of the equation. I can divide both sides by pi, can't I? Like this. And this will give me 3 over 2 r squared is equal to 75. Now, to get r, we need to times by 2, so it'll be 3r squared is equal to 150. Divide by 3, 150 divided by 3 is just 50. So therefore, we've got r squared is equal to 50, meaning that r is just going to equal the square root of 50. Now remember, we're dealing with a radius here, which is the length, so we don't need to do plus or minus. It's going to be the positive one. So we know that r is equal to root 50. This is good because remember, we need to figure out what d is. That's our job, the diameter, and that's equal to 2r. So what I'm going to do is put this in. So I'm going to do this here. I'm going to say that our d is just equal to 2r, and we know that r is now root 50. So the diameter is 2 root 50. So I'm going to put this here, 2 root 50. Now let's have a look at the form that they wanted it in. It says give your answer in the form a root b, where a is an integer, that's fine. B is a prime number. Is 50 a prime number? It's not. There are many factors. There's 10, there's 5, there's 25, there's many factors. So this isn't our answer, right? We need to use surds to simplify this, right? This is a non-calculate paper. So how do we do this? Now, you just got to remember your index laws, right? Now, one of them is if I have the square root, I'll do it here. If I have the square root of A times by B, this is just the same as the square root of A times the square root of B. Now, what that means is when you have something like this inside a surd, right? You want to break this down into two factors, and one of them should be a square number. Now, 50 is the same as 25 times by 2. So we can just write this as 2 and then 25 times by 2, and then according to this law on top, we could just separate the two surds. So it becomes 2 times root 25 and then root 2. Now, we know that the square root of 25 is just 5, so I'm going to put a 5 here, and then we've got root 2. Now, therefore, we've got 2 times 5, which is 10, and we've got root 2. So therefore, we can say that D is also equal to 10 root 2. It was equal to 2 root 50, but this is another way of writing it, 10 root 2. And now let's just double check. It says that A has to be an integer. 10 is an integer, that's fine. And B is a prime number. Is 2 a prime number? Yes, it is. It's the first prime number. So therefore, this is our answer here. So we could just say that the answer is just 10 root 2. And that is our answer for question 16. Okay, so question 17 says, make x the subject of the formula y is equal to 4 bracket 2x minus 7 divided by 5x plus 3. And this is how many marks? This is 4 marks. Okay, so with this one, what you want to do is, they told you to make x the subject of the formula. What that means is that you want to get x by itself. Now, firstly, we have to do a lot of algebra here, but I have a fraction. Now, you can't do any algebra when you've got a fraction here because you need to be able to expand, move things around, and so on and so forth. You can't do that when you've got a fraction. So firstly, I need to get rid of that fraction, and that means I need to get rid of that denominator 5x plus 3. And the way you do that is just by multiplying both sides by 5x plus 3. So the first step would be to multiply both sides, and that will give us y multiplied by 5x plus 3, right, is equal to 4 bracket 2x take 7. Now, we have gotten rid of the fractions, so we can just expand and simplify and move things around. So the next step is to just expand. So I'm going to have 5xy plus 3y, and this is equal to 8x minus 28. Now, we're trying to get x by itself, so our final line should be x is equal to blah, blah, blah. Now, what I notice is that the x terms, there are more than one. There are x's on both sides. Now, whenever that's the case, what you want to do is you want to move everything with x's to one side and everything without the x's to the other, right? That's the best thing to do. Now, what I'm going to do is I'm going to move the 5xy over to the right, and I'm going to move this minus 28 over to the left just to keep the terms positive. It doesn't make a difference. You will get the same thing, but I'm going to do it this way. If I do this, on this side, it's going to be 3y. If I minus that 28, that will become a plus 28 here. And then if I move that 5xy over, it will become 8x minus 5xy. Now, once you've done this and you've gotten all your x terms on one side and all of your terms without the x onto the other, what you need to do to get x, you need to factorize, right? Now, we can see that x appears twice on this right-hand side. So I can take it out and it will just be 8 minus 5y in the bracket. So it'll be x times 8 minus 5y. I've got 3y plus 28. Now, to get x by itself, now remember, this is just a factor here. We need to get rid of this factor to get the x on its own. We need to divide because it's multiplying at the moment. So therefore, we're just going to divide both sides by that factor of 8 minus 5y. Divide by 8 minus 5y. And this will give you 3y plus 28 divided by 8 minus 5y. And this is equal to x. So therefore, you can say that x is just equal to 3y plus 28 divided by 8 minus 5y. And that will be your answer. And that will give you 4 marks. Okay, so question 18 says 7 kilograms of carrots and 5 kilograms of tomatoes cost a total of 480p. The cost of 1 kilogram of carrots to the cost of 1 kilogram of tomatoes is in the ratio of 5 to 9. We need to work out the cost of 1 kilogram of carrots and the cost of 1 kilogram of tomatoes. Okay, so with this one, now what I can see is that I've got two variables. I've got carrots and tomatoes, and I've got a bit of information about both. I've got two sentences. I've got sentence 1, which tells us about the cost of both of them together. And I've got sentence 2, which tells us about the ratio. Now, what I'm going to use, I'm going to define these variables. I'm going to say C. This is just going to represent 1 kilogram of carrots and T is going to represent 1 kilograms of tomatoes. And our job is to find C and T. Now, these are variables, these are letters, and we need to find both of them. There are two. This is just simultaneous equations in disguise. Now, let's see why. Now, if I go to the first sentence, right, they've told us that 7 kilograms of carrots, right, that must mean 7C, right, 7 lots of C, and 5 kilograms of tomatoes. So that must mean 5D, right? These two must total 480 pence. So that must mean I can say that 7C plus 5T is equal to 480. And that would be equation 1. Now, sentence 2 tells us about the ratios, right? They've told us that the ratio of the carrots to tomatoes is 5 to 9. So I'm going to say here that C to T must be equal to 5 to 9. Now, we're trying to solve this simultaneous equation, right? And we've got a ratio here. Now, what I always tell my students is whenever you see ratios involved with equations, you can actually create equations as well. You can just write this as a fraction. You could always write a ratio as a fraction as well. So what you could do here is just divide these two. It'll be C divided by T, and this is equal to 5 over 9. And you can do this with any ratio. All you need to do is just divide them and make them equal to whatever they are. Now, we've got C divided by T is equal to 5 over 9. Now, this is not really a nice form because there's fractions here. We don't like fractions. So I'm going to cross multiply. So I'm going to do the 9 times the C. That will give me 9C here. Now I'm going to do the T times the 5, which is 5T here. Now, this will be our equation 2. So I'm going to put this over here. Oh, you know what? I'm going to write out again just so it's clear. 9C is equal to 5T. So when I look at these two equations, let me just line these up here. Right? This is equation 2. Now, what I notice about these two equations is that if I actually look closely, is that I can see I've got 5t in both, right? But the good thing is that with the second equation, I know what 5t is equal to. It's just equal to 9c. Meaning that this 5t in the first equation we can replace with 9c because 9c is equal to 5t. So we could say then that must mean for equation 1, right? We have 7c plus 5t, but we know that 5t is 9c, so 7c plus 9c must be equal to 480. And that way we just have an equation in terms of one variable, c, that we can easily solve now. So doing this, 7 plus 9 is 16, so it's going to be 16c is equal to 480. Now, to get c, we just need to divide by 16. So I've got 480 divided by 16. I know that 48 divided by 16 is 3, so 480 divided by 16 must be 30. So the cost of 1 kilogram of carrots is just 30 pence. So now we've solved C, we can just easily find out what T is. So let's go to this equation here, right? So we know that 9C is equal to 5T, but we know that C is 30 now. So I'm going to say that 9 times 30 must be equal to 5T. Now 9 times 30, 9 times 3 is 27, so this must be 270 is equal to 5t. Now to get t, we need to divide by 5. So we're going to have 270 divided by 5 is equal to t. Now 270 divided by 10 is 27. Dividing by 5 is just doubling that. So 27 times 2 is 54. So therefore we could say that t is just equal to 54. And we have found C and T. So we can just say that carrots is just equal to 30p and the tomatoes is just equal to 54p. And that's it. That will give you 4 marks and that's question 18 finished. Okay, so question 19 says the menu in a restaurant has starters, main courses, and desserts. There are 5 starters, there are 12 main courses, and there are X desserts. There are 420 different ways to choose one starter, one main course, and one dessert. Work out the value of X, and this is just 2 marks. So all you're doing here is just using the product rule for counting, which states that, for example, if I have n ways within one task and I have n ways to do a second task, then the amount of different ways I can do both tasks together is just going to be the product m times by n, and that just extends for 2 tasks, 3 tasks, 4 tasks, whatever, however many tasks you have. All you need to do is just multiply the different possibilities together. So in this case, they've told us how many different ways there are, but that will just be equal to, we have 5 starters, so there's 5 possibilities for the starter. There are 12 main courses, so 12 possibilities there, and there are X desserts. So we're going to have X here, and this has to equal 420. So all we need to do is just work this out. Now 5 times 12 is 60. So this becomes 60x is equal to 420. Now that must mean that x is just equal to 420 divided by 60. Cancel the zeros. This is just 42 over 6, which is just 7. So there are 7 desserts, right? And that is what x is equal to. And that's question 19 finished. Okay, so question 20 says, for x is greater than or equal to 0, the functions f and g are such that f of x is equal to 3x plus 4, and g of x is equal to the root x plus 2 all over 5. And part A says we need to find the inverse of g. Now, whenever you're doing the inverse, all you want to do is, well, we're dealing with g of x here. You always replace g of x with y. So I'm going to say y is equal to root x plus 2 all over 5. And then what I do is you're going to interchange, you're going to swap over x's and y's. So it becomes x will go here, and it'll be root y plus 2 all over 5. And then what you want to do now is just make y the subject. Whatever you get when you make y the subject will be your inverse function. So let's go ahead and do this. I'm going to times both sides by 5. So it'll be 5x is equal to root y plus 2. Now do the rest here. And then I'm going to take 2 over. So it's going to be 5x minus 2 is equal to root y. And then to get y, we need to square both sides. So it becomes 5x minus 2 all squared is equal to y. And now I've made y the subject. I'm going to replace y with the inverse of g. So therefore, we have the inverse of g is just equal to 5x minus 2 all squared. And this is your answer for part A. And that's 2 marks. Okay, now part B says we need to solve g of f of x is equal to 3. Okay, now g of f of x, let's have a look. G of f of x, what I always do when I'm doing this with my students, right, is I actually put an extra bracket. I'm going to put this in red. So I'm going to put this here, put this here. Now, what this tells me is that my input is going to be f of x. So I'm going to input f of x into my function for g, because that would be g of f of x, right? So if I do this, then if I write g of x, we know that g of x is just equal to root x plus 2 over 5. Now, whenever you're dealing with functions in general, right, whatever x is here, your input will be replaced by whatever x is on the right hand side. So these two in blue will be the same. Now, if I'm going to input the function for f, now remember f of x is just equal to 3x plus 4. So what I'm going to do is I'm going to plug in 3x plus 4 here, like this. Because remember, I'll just do it right here. F of x is equal to 3x plus 4. So that is why I'm plugging it into there, because I have it here. So in that case, remember what I told you. If this is 3x plus 4 here, then I also have to put it here as well. So it'll be 3x plus 4 plus 2 all over 5. And this will be our expression for g of f of x. So I'm going to write this as g of f of x. Now, we know this is equal to 3. So what we can say then is that, well, 3, the square root of 3x plus 4 plus 2 over 5 has to equal 3. So now solving this, how much room do I have? I've got a bit of room, I do it underneath. So this will be times both sides by 5. It's going to be root 3x plus 4 is equal to, sorry, not equal to, plus 2 is equal to the 15. And then now I'm going to take 2 away. So that will give me root 3x plus 4 is equal to 13. And then now I'm going to have to square both sides to get rid of the root here. So it'll be 3x plus 4 is equal to 13 squared, which is just 169. And to be fair, I don't need a bracket around there, do I? So I'm going to take this off. Now I'm just going to take 4 away. So it'll be 3x is equal to 169 take away 4 is 165. And then now I've got to do 165 divided by 3. Now I can just use the bust up method to do that. Now, 3 doesn't go into 1. 3 goes into 16 5 times with a remainder of 1. 3 goes into 15 5 times. So therefore, 165 divided by 3 is just 55. So therefore, x is just 55. And that is our answer for question 20. And that's it. Okay, so question 21 says A, B, and D are points on a circle with center O. CDE is the tangent to the circle at D, and we need to work out the size of angle ADC. Write down any circle theorems you use. Okay, so again, when you're dealing with circle theorems, right, what you need to do is know your circle theorems very, very well. You need to know them off by heart, because I don't think it's given to you in the exam. Now, with this one, we need to ask ourselves, well, what circle theorems are applicable? Now, firstly, before that, actually, the size of angle ADC is what we need to find. Let's mark that. ADC would be this angle right here. This is the angle that we're trying to find. Now, what I have here is that I've actually got this angle here, which is at the center. And there is a theorem, a circle theorem, that relates the angle at the center with the angle at the circumference. And that is that the angle at the center is just twice the angle at the circumference. Now, with that being said, this is a special case. This question here and the way it's set up is a special case of that theorem. We can actually apply it here, and I'll show you why. So this one is the angle at the center, and this actually here is going to be the angle at the circumference, which will be half of it, which is 32 degrees. And I'll put a graphic just to demonstrate why we can use this and why it's a special case. So this is just be aware of this moving forward, right? Now, doing this, I'm going to put this as 32. Now, since it's 32 degrees, we have a triangle here, uh, and we have a missing angle, right? These three make angles in this triangle here, and we can easily find out what that angle is. So all we need to do for that one is we're going to just do 32 plus 51. This is quite clearly 83. And then to get that angle, which I'll highlight in green, right? This angle here is just going to be 180 take away 83. 180 take away 83, and then this is equal to 97. And I'll label this 97. And that would mean that, remember, this angle in green is vertically opposite this angle here. That must mean that this is 97 too. So I'll put this in there and I'll highlight that as green as well. And then I will just annotate, because it says we need to use the circle. We need to write down any circle theorems used. So this one here, we're going to just say that we're going to use the circle theorem, that angles at the center is twice the angle at the circumference. Now again, so continuing now, these two angles are the same because they're vertically opposite. I've got another triangle here where I have two angles and a missing angle here. So I can actually work out what this angle is, and I'm going to highlight this in pink. This angle right here. Now all we need to do is add 64 and 97 together. So I'll do 64 plus 97. Now 60 plus 90 is 150. 60 plus 90 is 150. 4 plus 7 is 11. So therefore this is just the same as 150 plus 11, which is 161. Meaning that this angle right here is just going to be 180 minus 161, which is just equal to 19. So therefore, this is just equal to 19 degrees, this angle here. Now, remember the angle that we're trying to find. We're trying to find out this angle ADC, which I will highlight in orange. This will be the angle that we're trying to find, angle ADC. Now, we've actually seen something that we actually haven't used yet. It says that CDE is the tangent to the circle at D, right? CDE is the tangent. Now remember from your circle theorems, right? If you have a circle, I'll just draw a quick circle like this. And then it's not really a circle, that's an oval, isn't it? Let me just do another one. So if I have a circle like this, and then I have a center, which is, let's say the center's here, and this is the radius, right? Let's say I've got a tangent line like this. We know that the tangent and the radius will meet at 90 degrees. So what that means is that for our question, let me get a yellow. It means that this angle here, ODC, must equal 90 degrees. But we actually have a part of it. Part of it is that pink angle, which is 19. And that must mean that this angle right here in orange, which is the angle that we're trying to find, this must be 90 degrees minus 19, which is just equal to 71 degrees. And that would be our answer. And then we could just finish off by saying that the tangent and the radius meet at 90 degrees. So always remember to get your circle theorems in for the final mark. And yeah, that was question 21, and that was 4 marks. And yeah, we're done. Okay, so question 22 says A, B, C, D, E, F, G, H is a cuboid. AF is equal to 6.8 centimeters and FC is equal to 13.6 centimeters. We need to work out the size of the angle between FC and the plane ABCD, and this is a 2-mark question. Now, straight away, this is quite clearly 3D trig. It's the exact same setup. They've told us to find the size of an angle between a line and a plane. 3D trigonometry. So what we want to do firstly is let's label our size that they've given us. They've told us that A to F is 6.8 centimeters, so I'm going to put this here. This is 6.8 centimeters here. Let me write centimeters actually. So I just write 6.8 centimeters. And also F to C, well, this is just going to be the line. Now, I always tell my students, whenever you're doing 3D trigonometry, think of this as a room. This is a 3D object. It's a room, right? The line F to C is going to be that line that is going diagonally from one corner of the room to the other, right? So I'm going to just put this here. Now, this here is apparently 13.6 centimeters. So I'll label this as 13.6 centimeters. Now, we need to work out the size of the angle between FC and the plane ABCD. So when you're doing 3D trigonometry, it's just your job to construct a right angle triangle and find the angle in question. Now, again, I always treat this as a 3D object, right? Now that's the line F to C, and I need to make an angle with the plane ABCD. Now the plane is just the floor, the surface. I need an angle, and it needs to be a right angle triangle, right? So what that means then for me is that I actually like to think of this as a zip line. So imagine there's somebody zip lining like this. Somebody zip lining like this, right? For me to be able to make an angle with F to C and the floor, I would need the line along the floor to be vertically below this zip line here, meaning that I'm going to go from C and I'm going to go all the way to A here, right? Because we can see that F and A are vertically, well, A is vertically below F, isn't it? So that way we know this is definitely the angle that we need to make, the triangle that we need to make. And the angle in question would be this angle made here. So for me, the job is completely, not completely done, but it's pretty much done because we've got our right angle triangle now. I'm going to put a right angle here, and we know that we're looking for this angle FCA. So what do we do? Remember, this is 3D trigonometry. Now that we've got our triangle, we could use trigonometry to figure out what trigonometric ratio we need. So let's label. This is the angle. Opposite the angle is always going to be the opposite side. So I'm going to call this the opposite side. This is opposite the right angle. This is the hypotenuse for sure. And then this is the adjacent. Now we need to figure out what the size of angle X is. So we need to figure out which uh, expression we use out of SOHCAHTOA. So I'm going to write SOH. I'm going to write Ka. I'm going to write Toa here. Now, quite clearly, we have the opposite side, right? So I'm going to highlight this as O. I'm going to highlight this as O, meaning that for sure it's definitely not going to be Ka. And then, as well as the opposite, we have the hypotenuse, which is H. So therefore, we're definitely choosing So, and we are not using Toa. So in that case, now we can just plug in everything that we know. So in that case, we're going to say, well, the sine of the angle, which we can see as X, right? This is equal to the opposite divided by the hypotenuse. And I'll just tidy this up a bit more. This will be the sine of X is equal to the opposite side, which is 6.8, divided by 13.6. Now, we need to figure out what X is, and this is trigonometry, and it's a non-calculate paper. Now, for me, when I look at this, well, it's 2 marks, right? And it's a non-calculate paper, so there must be some way to do it. Now, this fraction here is interesting. Because I'm dealing with a non-calculate paper, what I would do is I would make these integers, right? Make them whole numbers. And what I can do is, just to be on the safe side, let us multiply both top and bottom by 10, right? That will get rid of the decimal places, wouldn't it? 6.8 times 10 is 68. And then 13.6 times by 10 is just 136. And then, well, if you think about it, right? 68 looks about probably halfway between 136. Imagine you're just in an exam, right? Now, it actually is. If you do 68 times by 2, it's exactly 136, meaning that, well, if I want to simplify this, I'm just going to divide top and bottom by 68. Divide by 68. This will give me 1. This will give me 2. So essentially, what we're actually solving here is sine x is equal to 1 over 2. Now, remember, we don't have a calculator, so we need an angle that gives us 1/2. Now, if you notice this value here, 1/2, it should be familiar to you because this is just one of the exact trigonometric values that you need to memorize. So we need to figure out what x is based on the fact that sine of x is equal to 1/2. So what I'm going to do is I'm going to construct a table, and some of you may have seen this before, but there's a way to memorize your sines and cosines for exact trig. Now, I'm going to just do this here. So I'm going to write sine here. I'm going to write cosine here, and then I'm going to do a square root like this, and then I'm going to label the top here 0, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. And what you do is you're going to write 0, 1, 2, 3, 4, and then when you get to cos, you're going to reverse it. So 4, 3, 2, 1, 0, and you're going to divide this all by 2. Now, this table here allows you to figure out what trigonometric expression that you want, trigonometric value. So, for example, just a random example, let's say I wanted for example, the sine of 60 degrees. Now, what would that be based on this table? Well, sine is here, 60 degrees is here, so we need to look at this value here, which is 3. So I'd put a 3 here. Now, remember, this has a square root all over it. So this would have to have a square root like this, and then we need to divide by that 2. So that means that the sine of 60 is just root 3 over 2. You can check on your calculator. Now, why is this helpful? Because remember, we need an angle that will give us 1 over 2. So we know we're looking at the column, the row for sine, and we need 1, don't we? So we're just going to look here, aren't we? So look here. Now, we can see quite clearly this is when the angle is 30 degrees. So what that means then is that the sine of 30 degrees based on this table here would be 1 over 2. And that must mean that that is our angle x, isn't it? So you could just say here that x is just equal to 30 degrees. So just say x is equal to 30 degrees. And that is it. That will give you the 2 marks. And that's question 22 finished. Okay, so question 23 says, write 3 root 3 over 4 minus root 3 minus 2 over root 3 in the form a root 3 plus b divided by c, where a, b, and c are integers. Now, there's a lot going on here, but we can see quite clearly that this is a Surds question, right? Now, we've got this expression on the left, and we need to write it in terms of this on the right. Now, they've told us that c, most importantly, is an integer, right? That's a whole number. On the left, we've got surds. We've got irrational expressions on the left, and we need to get it to a whole number. That means we need to rationalize. So for me, looking at this question, I would rationalize the first fraction, rationalize the second fraction. Once I've rationalized those, just simply subtract the fractions and see what we get. So what I'm going to do is start with the first fraction. So 3 root 3 over 4 minus root 3. Now, to rationalize something like this, remember, we always multiply top and bottom by the exact same thing. So 4 under root 3, 4 under root 3. But then we're going to flip the sign. So it becomes a plus here. Now, I'm going to expand top and bottom. Doing this, we're going to do treat this like a bracket, 3 root 3 times by that. So I'm going to do this here. Let me just get a nice fraction bar. This will give me 12 root 3 for the first one. It's going to be 12 root 3. And this is going to give me the next term is going to be 3 root 3 times root 3. Now, something like this, I always do separately just to make sure I'm doing it correctly. I'll do it here. 3 root 3 times by root 3. Now, the root 3 and the root 3 we know is just 3 from our surd laws. So this is actually just the same as 3 multiplied by these two. Root 3 times root 3 is just 3. This is equal to 9. So therefore, this is just going to be a 9 here. And that one's done. That's absolutely fine. Now, the denominator, we're going to do this. We're going to use the FOIL method, aren't we? So it's going to be 4 times 4, right, which is 16. Then it's going to be 4 times root 3, which is a plus 4 root 3. And then we have minus root 3 times by 4, which is the exact same thing, but with a negative sign, like this. And then we've got root 3. So we've got minus root 3 times a positive root 3. So again, I'll do it here. Negative root 3 times by positive root 3. We know that there's just a minus here, so that will go there. Root 3 and a root 3 make a 3. So therefore, it's just minus 3 here. And then simplifying this a bit more, we're going to have just a 12 root 3 plus 9. And we're going to divide this by, now what happens here? Now these two, 4 root 3 and minus 4 root 3 will always cancel. So whenever you're rationalizing, you always know that the two terms in the middle will cancel. So I'm sure a lot of you will just go straight ahead and just even forget about this and just go to 16 take away 3, right? But yeah, that's just a quick one for anybody that was just wondering. But now we've done that, that cancels. 16 take away 3 is 13. So therefore, the first fraction we know can be written as 12 root 3 plus 9 over 13. So that one's done. Now let's go to the second fraction, which is just 2 over root 3. Now to rationalize something like this, all we need to do is just multiply top and bottom by the exact same expression on the bottom here, which is going to be root 3 over root 3. Now doing this is going to be 2 root 3 on the top, and then root 3 times root 3 will be 3, isn't it? So now we've rationalized both of the fractions here. Now we can just subtract them and see what we get. So I'm going to go ahead and do this now. So in that case, it's going to be 12 root 3 plus 9 over 13 minus 2 root 3 over 3. Now, these have different denominators. How do we subtract fractions with different denominators? We need an LCM, a common denominator, which will be quite clearly 39. 13 times 3 is 39. So I'm just going to write both of them with a 39, like this, and then like this. Now, if the first fraction is now 39, the denominator, that means I've multiplied this by 3, haven't I? So that means I have to do the exact same to the top here. So what I will be doing essentially is I will just be doing 3 multiplied by 12 root 3 plus 9. And I'll expand that in a second. And then this one has gone from a 3 to a 39. So that means I've multiplied by 13. Meaning that I have to multiply this one by 13 as well. So it will be 2 root 3 times 13, which is just going to be 26 root 3. So that's fine. Now we can just simplify. So I'll go ahead and do this now. Now this one, if I expand this bracket, 3 times 12 is 36. So it would be 36 root 3 plus, and then 3 times 9 is 27, isn't it? So I have 27 here. And this is all over 39. And then I'm going to minus 26 root 3. And this will be over 39. Now this I can just combine. So I have 36 root 3 plus 27 minus 26 root 3. And this is going to be all over 39. I'll tidy this up a bit more. We can see that we've got a 36 root 3 here, and we're taking away 26 lots of root 3 here. That will leave us with 10 lots of root 3 altogether. So it'll be 10 root 3 plus 27 all over 39. And that will be our final answer, and that will give you the 4 marks. And that is question 23 finished. Okay, so question 24 says, find the set of possible values of x for which 4x squared minus 25 is less than 0 and 12 minus 5x minus 3x squared is greater than 0. You must show all your work, and this is for 5 marks. Now, this one here is what we call a quadratic inequality question, right? Now, the way you solve quadratic inequalities is by sketching them. You need to sketch the quadratics to be able to visualize and actually see where your possible values are going to lie. Now, in this case, we've got 2 inequalities. So the way you'd solve 2 inequalities, and that would just be in general, they don't even have to be quadratic, but the way you solve 2 inequalities is you solve them separately, and then your answer at the end will be where both of the inequalities are satisfied at the same time. So what we need to do with this one is solve the 4x squared minus 25 is less than 0, solve the 12 minus 5x minus 3x squared is greater than 0, see where both of them are satisfied at the same time, and that will be our final answer. So let's go ahead and start with the inequality on the left. We need to sketch this. So firstly, I'm going to say we have y is equal to 4x squared minus 25, which is what we're trying to sketch. Now I'm going to get a set of axes here. Now, whenever you're sketching graphs, and not just quadratics in general, you need to have a general idea of what the graph is going to look like. Now, quadratics, let me just make this a bit neater. 4x squared. Now, quadratics have a specific shape. They are U shapes, and I'll just do it here in the corner. So if I have a U like this is when your coefficient or the term in front of the x squared term is positive. So I write plus x squared here. And then the other type of quadratic is when you have an n or a frown, as my teacher liked to call it. So this will be when it's negative, right? So what we can see here is that the first quadratic will have this shape because it's a 4, that's positive, and the second quadratic will have this shape on the bottom here because that is a negative 3. So that is good. We have an idea of what the graph will look like. Now let's go ahead and sketch it. How do we sketch quadratics? We need the intercepts. So straight away, if I look at this one here, I can see that the y-intercept must be 25, isn't it? Minus 25, sorry. So I'm going to put minus 25 here. Now that I've got the y-intercept, let me just label this and this. I need to figure out what the x-intercepts are, and that is the roots of the equation. And remember, the roots or the x-intercepts is when your y value is 0. Because if you think about it, if you're along the x-axis, you haven't gone up or down. So y has to be 0 there. So what we need to do to get that is we just need to make this equal to 0. So we're going to have 0 is equal to 4x squared minus 25, and we need to solve this. And I'll do this over here, actually. Let me get this here. I'll do this over here. Doing this over here, I'm going to move the minus 25 to the left. So I have 25 is equal to 4x squared. And I'm going to divide by 4. So I have 25 over 4 is equal to x squared, meaning that I need to square root. Now remember, you're solving an equation. When you square root, you need to do plus or minus. So it's going to be the square root of, and I'm going to put plus or minus 25 over 4. Now, we do not have a calculator. How do we solve this without a calculator? This is where your surd laws come in. Now remember, when you square root a fraction, it's just the same as square root in each of the numerator and the denominator individually. So it's just going to be the same as the square root of 25 divided by the square root of 4. And then from here, I'll just say x is equal to plus or minus square root of 25 is 5, square root of 4 is 2. So therefore, x is equal to plus or minus 5 over 2, which is just 2.5, isn't it? So what I'll do is I'll just put this here. So let's just say minus 5 over 2 is here. And let's say plus 5 over 2 is here. That means that the graph, I'll do it in green. The graph will just be a U shape through these 3 points. So it's just going to look like this. It's just going to look like this, right? And it's exactly the same distance away from the origin, 5 over 2 and minus 5 over 2. So the turning point is going to be on the y-intercept. So this is what the graph will look like. And I'll just put an arrow here. So we've sketched this graph. Now, what do we do when we sketch it? Now, there's another thing you need to know about quadratic inequalities is when you are dealing with them, if they ask you for example, less than 0, when they ask you for you to solve it for when the graph is less than 0, this just means that you're looking below the x-axis. That's just one thing to note, below the x-axis. And then if they're asking you for greater than 0, that means you have to look above the x-axis. So that's just something to note. Now, in our case, it's less than 0 for this inequality, so we need to look below the x-axis. So I'm going to highlight the graph below the x-axis, which would be here. Now, once you've done this, you have to ask yourself, okay, well, that's fine. We've identified the region. What values of x is this for, though, right? And we can see quite clearly it's going to be between minus 5 over 2 and 5 over 2, right? Meaning that your answer to this inequality is just going to be minus 5 over 2, right? This has to be less than x, and x has to be less than 5 over 2. And that will be the first solution, right? So that one is done. I'm going to put a tick. That's fine. Now what we need to do is sketch the second graph, and I'll do this here. So I'll do it. It's y is equal to, and it was, let me just double check, 12 minus 5x, 12 minus 5x minus 3x squared. And again, what do we know that? We know that this is a negative x squared term. So we know it's going to have this N shape here. And what I'll do, just so it's super clear, I'm going to just swap the order around because this is a quadratic. Let us make it a bit more familiar. We know that the x squared term is always first. So I'm going to write this as minus 3x squared minus 5x and then plus 12, right? And from here, it's actually quite easy to see what the y-intercept is. To be fair, some of you may have been able to see it already, but I just want to be super clear because I'm making a video. So I'm going to just draw a sketch here. Now the y-intercept again is just going to be the number on the end, which is a positive 12. So doing this, I'm going to put a 12 here, like this. And now we need to figure out what the roots are. Now remember, the roots are just when y is equal to 0. So we just need to solve this equation equal to 0, which I'll do over here. So I'm going to have 0 is equal to, let me just rub this out, distracted me. So 0 is equal to minus 3x squared minus 5x plus 12. And then what I'm going to do now is I'm actually going to move everything from right to left because I'm solving a quadratic. I would want the x squared term to be positive. So if I move everything from right to left, I'm going to have 3x squared plus 5x minus 12 is equal to 0. Now, how do we solve this quadratic? There are many ways. You can complete the square, you can use the quadratic formula, you can factorize. Now, if something can be factorized, if a quadratic can be factorized, I would always go with that. Now, can it be factorized is the question. We need to apply the AC method because there is a number in front of the x squared term. So I'm going to do 3 times minus 12. 3 times minus 12 is equal to negative 36. So that means that we need two factors of negative 36, which will add to make positive 5, which is 9 and minus 4, isn't it? 9 plus minus 4 is positive 5. 9 times minus 4 is minus 36, so it's this one. And then we're going to have 3x squared, and then instead of writing 5x, you're going to rewrite the 5x in terms of what two numbers add to make it, which is going to be a plus 9x, and we're going to take 4x, and then we're going to put minus 12. Oops, yeah, minus 12 is equal to 0. So that's fine. And then now we can see 9x minus 4x is 5x. So this is definitely okay. Now, once you get here, you're going to split it down the middle and factorize the first two terms and then factorize the last two terms. So if I do this, I'm going to have a 3x and it's going to be x plus 3. And then what can I take up from the last two is going to be minus 4. And then this will have to be an x here, and this will have to be a plus 3. And we can see quite clearly that these brackets are exactly the same, which is what you expect when you do this method here. That means we can take these out of these two terms. So we're going to factorize out this bracket here of x plus 3 out of both. And what will that leave us with? Well, this is here. This is here, right? Now that leaves us with this for the first term, and this for the second term. So altogether, it's just going to be 3x take 4. And this is equal to 0. So now we factorized. What do we do to solve? Remember, you're just going to set each bracket equal to 0. So I'm going to have x plus 3 is equal to 0. That would mean that x is equal to minus 3. And I'll have 3x minus 4 is equal to 0. That means that 3x is equal to 4. And that means that x must be equal to 4 over 3. So now we've got our two solutions. Now we're able to plot this on the graph, and then now we can sketch. So if I was to put this on the graph, let's just say minus 3 is maybe around here. And 4/3, well, you don't have a calculator, but you should know that 4/3 is just 1.3 recurring. So it's just going to be a bit after 1. So I'll just say 4/3 is around here. And what that will mean is that the graph will, what color? I used green. I'll use green here. The graph will just look like this. It's going to be, remember, it's negative x squared. So we know it's going to take this shape here. So you're just going to draw that shape through the points. Now, this one is going to have a maximum just a bit to the left of the origin, like this here. Like this. So this is what the graph will look like. Now, we sketched the graph. This is great. Now remember, we need to go back to our inequality now. The inequality asks us for when the graph is greater than 0. And we know that that means we're looking above the x-axis. So let's highlight where that happens. Above the x-axis will be for these values right here. These values right here. And then you ask yourself, well, for what values of x is that satisfied for? And that would be between minus 3 and 4 over 3, our roots. So we could say that this inequality is now solved, right? And the answer is going to be minus 3 is less than x, and that means x is greater than 4 over 3. So now we've actually solved both of these inequalities. Now remember how I said we solve these types of questions. We solve both of them individually, and then your final answer will be where both inequalities are satisfied at the same time. Now this is currently a 4-mark, this is a 5-mark question, and we are currently at 4 marks. To get the final 5th mark, we need to figure out where both of them are satisfied at the same time. And what I like to do with these types of questions is draw a sketch. So firstly, I'm going to write those inequalities again. It was minus 5 over 2, x and 5 over 2 for the first one, and the second one is that one right there, minus 3 and then x, and then oops, I forgot this less than symbol here to be fair, and then 4 over 3. So now I'm going to draw a number line, right, similar to those types of 1 markers that come up and they ask you to just draw the inequality. Now I'm going to put this as 0, I'm going to put this as 1, I'm going to put this as 2, I'm going to put this as 3, 4, and so on and so forth. Put this here, minus 1, minus 2, minus 3, minus 4, minus 5, like this. So now I'm going to draw a line to represent both of these. Now this one, the first one, now we are not including minus 5 over 2 and 5 over 2, which by the way is 2.5, isn't it? So what I'm going to do, I'm going to draw it in green here. That's going to be around here. It's going to be minus 5 over 2. This is going to be 5 over 2. And then because we're not including these values, I'm going to draw an open circle on here. I'm going to draw a line next to them, like this. Like that. Let me just straighten it up. Straighten up. So it's like this here, right? So this is that inequality. Now the second one is between minus 3 and 4/3, right? So I'll do this in red. Minus 3 is right here. I'll just do minus 3 right here. And then 4/3, remember I said that's 1.3 recurrent. So it's going to be around here, isn't it? It's going to be 4 over 3, like this. And I'll do this one. And this will be an open circle here. And this will be another open circle right here, isn't it? And then now I'm going to draw a line to connect these two. And that will be like this. So I'll just straighten this up again. So it's like this here. Now, the answer to the question is where both of these inequalities are satisfied at the same time. Now, you can see quite clearly, right? Where they are satisfied would be where the lines are in sync in terms of vertically, right? And we can see that would be for values between here, right? Remember this here is minus 5 over 2. And here, right here. Let me just line this up so it's nice. And so it's clear for this value right here, like this. So we can see quite clearly, I'm just going to highlight that part. It's just going to be in this region here, isn't it? And what we can see from here is that would be for the lower bound, right? The lower boundary is going to be the lower boundary of the inequality on the bottom, which is minus 5 over 2. So I'm going to circle this here. Minus 5 over 2, right? That's going to be the first part of the answer. I'll circle this too so it's clear as well. Minus 5 over 2. And then we can see that the other part is the upper boundary of the inequality at the top, which is 4 over 3 right here, which is right here, like this. So therefore, the answer is just going to be minus 5 over 2, which is less than x, and x has to be less than 4 over 3. And that will give you the full 5 marks. And yeah, that's question 24 done, and that's paper 1 done. Hi guys, Daniel here. Hope you're doing well. So yeah, we made it to the end of paper 1. So hopefully you didn't find the paper too challenging. But if there were any misconceptions or anything that you found a bit tricky, I'm hoping that the video has helped you understand it better and you're in a better position for your exams in May. And yeah, again, thanks for all your support. If you did find the video helpful, feel free to drop a like, comment, and subscribe, and share with anyone that you think would benefit. And as well as that, paper 2 and paper 3 are on the way. So I'm currently in the making of them. I'm recording them, nearly finished, and they will be uploaded as soon as they are done, which is not going to be too far away from when this video has been uploaded. But yeah, thanks again for all your support. Good luck with the rest of your exams, and I'll see you for paper 2 and paper 3. Take care. Bye bye.